Hi, everyone, and thanks for watching. My name is Connor Crank, and I am the project coordinator for the Institute of Water Research at Michigan State University. The IWR is one of 54 federally designated water institutes created under the Water Resources Research Act of 1964 and is supported by the USGS. The IWR is involved in a number of modeling projects exploring the impacts that modified landscapes have on groundwater recharge and is interested in the positive impacts that groundwater recharge can have on stream health. In this presentation, I'm going to talk about a USDA NRCS Regional Conservation Partnership Program project that's currently being offered through the IWR that aims at improving fish habitat in the Maple River watershed. The IWR, in partnership with the NRCS, is offering conservation funding through a 5-year Regional Conservation Partnership Program, or RCPP for short, for agricultural practices in the Maple River. These RCPPs allow the NRCS, conservation partners, and producers to work together to address whatever issues they want to target in their watershed. For this project, we're looking to improve fish habitat and water quality within the Maple River watershed through increasing groundwater replenishment and reducing sediment. Many of Michigan's streams are fed by groundwater, which provides those streams with a cool and steady base flow. Several economically and ecologically important fish species in Michigan and the Great Lakes region in general, such as different types of trout and salmon, require cool or cold water streams to thrive. Groundwater extraction competes for those flows and can also divert critical flows away, which negatively impacts those fish populations that rely on them. The increasing demands on agricultural production also have the potential to increase demands for irrigation and fertilizer inputs, which of course further aggravates the challenges to groundwater quality and quantity. The Maple River watershed is a tributary of the Grand River, and it drains into Lake Michigan. The upper portion of the Maple River watershed is nearly 80% agriculture, which provides a lot of opportunities for sediment and nutrients to enter those streams. The upper Maple River Watershed Management Plan identified sediment as the highest priority pollutant in the area, along with nutrients, temperature, and bacteria. Additionally, a number of subwatersheds in the Maple River are currently experiencing pressure from groundwater withdrawals, which compete for base flow in the streams. So one of the goals of this project is to try and return stream flows within the Maple River watershed to the original values that were identified in Michigan's water withdrawal tool. So in 2009, Michigan began tracking high capacity water withdrawals, which are just defined as any water withdrawal greater than 70 gallons per minute. And they are tracking those through the water withdrawal assessment tool. So in this system, the water withdrawal assessment tool system, about 90% of all of the withdrawal requests are for irrigation purposes. So in the Maple River watershed since 2009, there have been about 221 new withdrawal requests in the WWAT. And out of those 221 requests, 103 of them fell into what's termed Zone D, which basically means that they would require either a site-specific review or modifications to ensure that they wouldn't have an adverse impact on nearby fish populations. And I'll talk a little bit more about those zones here in just a second. I'll provide a little bit of brief background info on that water withdrawal assessment tool. So it was developed by the MDEQ, MDNR, USGS, and the IWR to assess the impacts of new high-capacity water withdrawals. So it all starts with a user, or this friendly lady on your left here, who wants to propose a new water withdrawal. And this is all done within an online tool. So first, the user would navigate to the location of their proposed withdrawal using an online map within the tool. The user would then enter some data on the characteristics of that withdrawal, such as the depth, the aquifer, pumping capacity, pumping schedule, and so on. There are 3 main types of models that are running in the background of this online tool. A groundwater depletion model, a fish response model, and some stream flow models, which all work together to generate that output of an A, B, C, or D management zone for each proposed water withdrawal. So an output of an A or B zone indicates that that water withdrawal is unlikely to have an adverse impact on any of the nearby fish populations. Whereas water withdrawals that would fall within a C or D zone would require either a site-specific review or modifications. So once that assessment process is complete, the user would register their withdrawal, and that withdrawal information is then added to this accounting database that removes the amount of water being proposed in that new withdrawal from the amount of water within that sub-watershed. So how were those A, B, C, and D management categories established? That process started off with the state of Michigan categorizing all of its streams into 11 different stream types, which are shown in this map on the right. For each of those 11 stream types, they identified the characteristic fish populations and the thriving fish populations. So of course, as you remove some of the index flow from a stream, which is shown on the x-axis of the graph here, index flow is also known as base flow, you inevitably would lose some of your fish populations. So the DNR met with their stakeholders to determine what percentage of the thriving and characteristic fish populations they would be willing to lose. So you can see here that water withdrawals categorized as Zone A withdrawals have a reduction of 10% of the thriving fish populations. Zone B withdrawals have a reduction of 20% of the thriving fish populations. Zone C has a 10% reduction in characteristic fish populations. And then Zone D withdrawals are any withdrawal that has a greater than 10% reduction in characteristic fish populations. So how does this Maple River RCPP project work to accomplish its goal of increasing groundwater replenishment? One way that we do that is through trying to increase infiltration. Infiltration is basically just water soaking into the ground. Less than 1% of the Earth's water infiltrates the soil and becomes groundwater. So whenever you have a precipitation event, that precip is basically going to act either as runoff across the land surface that enters into streams, or it can act as evapotranspiration to plants, and then some of it will work its way into the groundwater as groundwater recharge, or into the stream as base flow. So in Michigan, the majority of streams are fed by base flow. So groundwater entering into a stream is about 52 degrees and occurs as a very steady, even flow. Overland or surface flow, on the other hand, comes off of the landscape and enters streams at an average of 70 to 77 degrees Fahrenheit, and it occurs in a much flashier manner, which can be very disruptive to fish populations. So here's a really simple example of infiltration and the impacts from pumping. So there's a precipitation event happening in this first blurb here. The little gray cloud is raining on the hillside. So some of that water is entering this system as groundwater recharge and base flow into the stream. If you add a water withdrawal in the form of a well, that withdrawal has the potential to divert some of that flow away from the flow that would normally be entering the stream. So those flows impact not only the amount of water that's contained within the stream and the lake or pond, but also the temperature of the water within the stream. And of course, different types of ground cover also play a major role in infiltration and groundwater replenishment. So a major component of this project is trying to change the types of ground cover on agricultural lands to improve groundwater quality and quantity. So this concept can be demonstrated with a rain simulator like the one that's shown here from North Dakota State Extension. So each of these 4 metal planters contain the same type of soil, but they all have different types of ground cover. So the water that goes off into those front jars is representative of runoff. And then the water contained in the jars in the back is the water that soaks through the soil and represents groundwater recharge. So you can see the bare soil in that first metal planter box right there has a lot of groundwater runoff in that first jar in the front, and then very little groundwater recharge in that back jar. And the overall water quality in the front and the back jars is much worse compared to the water quality from the other 3 types of cover. Summer water temperature also plays a major factor in fish development, survival, and distribution. So lots of factors would influence that temperature, including precipitation, evapotranspiration, infiltration, aquifer storage, aquifer loss, aquifer transmissivity. So while we don't have control over lots of the drivers of fish habitat, we do have some control over evapotranspiration and infiltration. We can control those a little bit by the use of different conservation practices. So what we want to do in this project is modify the landscape to help shape some of those drivers of fish habitat. So these are some examples that we pulled directly out from our project. These examples are all, going to be spatially explicit, and they were run through our models in real time. So farmer 1 here switched their 100 acres from conventional tillage to no-till, which resulted in an increase in groundwater recharge of about 275,000 gallons annually. Farmer 2 moved their 100 acres, or excuse me, 80 acres from a corn-soy rotation to pasture, which resulted in a 4.6 million gallon annual increase in groundwater recharge. And then farmer 3 enrolled their 200 acres from conventional tillage, moved into conservation tillage, resulting in a 375,000 gallon increase in groundwater recharge annually. So as you can see, these shifts in management practices definitely allow the numbers for groundwater recharge gallons per year to really quickly add up. So now I'll switch gears a little bit and just talk a little bit more directly about the Maple River RCPP project itself and kind of how it operates. So we are now in our 2nd year of the project. It's a 5-year project all in total. We were contracted for a total of $1.5 million through the NRCS and partner contributions. And about 600,000 of those dollars are made available for financial assistance to producers. So the goal of this project is to use select conservation practices to improve infiltration, return stream flows within the Maple River, to their original values within that water withdrawal assessment tool, and to help meet contaminant reduction goals for nutrients, sediment, and temperature, which were outlined under the approved Maple River Watershed Management Plan. We also want to try to quantify those reductions and model their impact on improving annual groundwater replenishment through infiltration. And ultimately, the goal is to improve water quality and fish habitat within the Maple River. So the goal is to have a 5-year total of 4,334 equip acres contracted into the RCPP. 155,436,000 gallons of water replenished, and 3,467,000 pounds of sediment reduced. These numbers were developed to help achieve the appropriate flows for fish habitat and reach those milestones that were identified and outlined in the watershed management plan. Initially, we were focused on just enhancing recharge, but in an effort to be responsive to feedback from our project partners, we revised the program in 2019 to break up the watershed into priority areas for recharge and sediment. So for those recharge priority areas, the criteria for those would be streams that are at a high risk for adverse impacts from water withdrawals. Those would be watersheds with cool, cold, or cold transitional streams. And then for the sediment priority areas, the criteria for those would be streams that are not in the recharge priority areas, of course. And those would be areas where the stream temperature tends to be warmer and the fish are not as sensitive to changes in base flow. So here's a map which shows those recharge and sediment priority areas within the Maple River watershed. The recharge priority areas are shown there in blue, and the sediment priority areas are shown in green. So here's the kind of overview of the process for how to get producers enrolled into this program. The eligibility process begins with a technician using the GLWMS, which is the Great Lakes Watershed Management System, to pre-screen applications. So the GLWMS is an ever-evolving mapping, analysis, and reporting system that's used to improve water resource management across the Great Lakes. That system allows users to do things like estimating non-point source pollutant loads at the field and at watershed scales. They can determine potential reductions in non-point source pollutants based on implemented best management practices, or BMPs. Assess potential increases in groundwater recharge based on those implemented BMPs. And then you can use it to generate PDF reports that contain field scale analysis results and detailed maps, and then use those results to track watershed improvements over time. So once that report has been put together in GLWMS using the information from the producer, the technician would sit down and talk with the producer about what options they have in terms of which of their fields are eligible, which management practices would be most suited to them for those fields, and then what the funding opportunity would look like, what the dollar amounts would be. And then the technician would submit the application with whatever the technician and the producer decided to do. They would submit that to the NRCS containing that criteria and then the points that are taken from the GLWMS report. And that information would be used to rank the producer's fields in EQIP, and then the producer would be able to get enrolled into the program. So this is a list of the eligible conservation practices that are being offered through the Maple River RCPP project this year. Those include conservation crop rotation, conservation cover, critical area planting, drainage water management, filter strips, and lots of others like no-till or reduced till. As you can see, we are no longer offering drainage or irrigation water management plans. Those were offered in the first year, but they are now contracted through regular EQIP. Additionally, cover crops are available as an eligible practice only in those sediment priority watershed areas. So to wrap up my presentation, we just want to thank all of our project partners for being so instrumental in making this all possible. And then, of course, thank you so much for watching, and please feel free to reach out to me or any of my coworkers at the IWR. Our contact information is listed here with any questions that you might have about this project or other projects we have going on at the IWR. Additionally, there's lots of helpful information about this Maple River RCPP project available at its website, which is www.maplercpp.weebly.com.